Hello, hello. I'm doing a medium here called Queen's Attack number 2. I don't think I ever did number 1, so let's figure this one out. I'm going to start my timer, and here we go. You will be given a square chessboard with one queen and a number of obstacles placed on it. Determine how many squares the queen can attack. A queen is standing on an n by n chessboard. The chessboard's rows are numbered 1 to n from bottom to top, like this, okay? Its columns are numbered 1 to n going from left to right. Each square is referenced as a tuple, RC, referring to the row and column respectively. The queen is at a starting position of R, Q, or C and CQ. In a single move, she can attack any square in 8 directions, typical chess queen. There are obstacles on the chessboard, each preventing the queen from attacking any square beyond it on the path. For example, an obstacle at location 3-5 would prevent the queen from attacking those cells in that diagonal. Effectively, this is like you're being blocked by your own men. I think that's the idea. Given the queen's position and the locations of all obstacles, find and print the number of squares the queen can attack, not the actual square positions, from her position on the board. And she has a bunch of obstacles. Oh, so the actual board could also be very different. I see that. Okay, so you have a bunch of stuff, a bunch of parameters here. So n is equal to the grid. So I want to actually just take a quick note of that. I mean, my familiarity with grids is not to approach it in, especially with game problems like this, is it's kind of annoying, but to basically just hard code the directions, and just the queen can go up and down and left and right, and that's basically 8 different directions, and to just code those out straight up. So I need to worry about bouncing on the edge. And that's kind of bouncing on the edge and basically obstacles, and that's basically it. I think it makes practical sense to create a grid, so I think I want to do create grid, add obstacles, have a counter for number of moves possible, and then literally just go through all 8 directions, hard-coded. Considering bouncing on obstacles and edges, and that's my approach. It's not very elegant, but hey, it'll work. My grid, so let's say const grid equals, so it's array from there, and I do another one on array fill 0. Okay, let's try that. Okay, so we have an array of 4 by 4 with a bunch of zeros, and that is what I was expecting. That should be good. Okay, cool. Let me just move you down here. So I need to add my obstacles. Okay, so the column is fine. The columns are the same, but the row is kind of inverse. It doesn't really matter if it's 1 to 8 that way or 1 to 8 this way. So I don't think it matters actually, because I don't need to return the positions. I just need to return the number of moves. So it's kind of irrelevant how I implement it, as long as I'm consistent. So I will do it like this: for const RC of obstacles. Then I want my grid row C to equal an X or something, or a 1, to know that there's an obstacle there. So let's see what this looks like. Cannot set property 5 of undefined. Okay, so I forgot to mention that these are numbers. Okay, but they're in number starting from 1, so I need to make sure to -1 basically. That's all. Okay, fair enough. R -1, C -1. I don't think that will negatively affect anything too bad. I do need to keep in mind that the queen is also in a similar relative ordering. So here we go. We got some stuff on the board. Now I need to make a counter. Yeah. Okay, let's make a counter. 0. And we just hard code all of them with obstacles. So I just return counter. All right, cool. I can I'm just gonna I'm gonna place queen just to visualize it a little bit. Grid, is it Q RQ R underscore Q R underscore Q -1 and C underscore Q -1. I'm gonna say you're equal to Q for the queen. Okay, cool. So this, do I need to hard code it? I think so. Yeah. Okay. So I'm just gonna do it that way. I think that's definitely maybe the harder approach, but it's definitely also the one that I know will definitely work. So here I'm gonna go up. So this is gonna be a bunch of while loops, I think. Maybe it's better if I just like abstract this a little bit. Function check up. Oops. Get up. This is gonna. I'll take a grid. I'll take the green position. So the only thing I care about here is the Q row and the Q column. Because I'm going up, the only thing I care about is the column. Let counter equals 0. Okay, this is definitely long-winded, but I kind of knew that was going to happen. Let's do while. The column stays the same. You're going up, so the R. QR is greater than or equal to 0. We're going to do QR minus, and grid of QR and QC equals 0. The second it's not equal to 0, then we will not do anything. Counter ++, right? Just for posterity, I'm going to put an X on the grid just so that I can see where things have gone. And I can just say counter plus equals this position thing. This is a very weird implementation. It's supposed to be like this. Same thing here. This is a problem because I put queen at that position. That's why. So what do I need to do? I need to like not use this queen position then. Like this is just for my own visual. I mean, you're right about that though. X is all the way. Okay, it did go up. It replaced the current position, so I need to make sure not to include the current position, basically. Okay, so I'm going to put the queen back, and I'm going to skip over the start. So this is going to be like the starting position. So I'm going to say QR minus already because it needs to be that way. Okay, cool. So that went up. Okay, so that's 3. Perfect. Okay, so now I just need to do that for a bunch of them. Down. Right. Now the diagonals, right? So upper left. I'll call it up left. Upright. I should call it, I should be consistent, right? Uprights. Up left. So this is going to be down rights. All of all right. I think that was very, very long-winded, but it does make sense. And I think this is, I don't want to say it's like the most efficient, but I think it's just like one of the most understandable and just like hard. It's hard to screw up, you know. It's yet I have mistakes. So let's find out what's going on. Did not execute in time. So there are some efficiency issues here. All these did not execute in time. Okay, fair enough. I bet that's on very large boards. I assume that's like a huge board or something, right? Yeah, look at that. Look how huge that board is. So there's some math things going on that I could be doing. I could create a lookup table of the obstacles to quickly assess what's going to be a problem. Take like the row. I think if you do the row and the column, it's really easy to detect that, right? Like the distance. I can detect what's in the path by the simple properties of what counts as a column in a row as well as diagonal, right? So if I see anything in this column, I just need to calculate the difference between these two. So I need to be, so when I go through the obstacles, I just need to look at the obstacles array then. Let me actually, I think I'm going to reset this real quick. Let me just do that. Let me rip the bandage off. Oh, sigh. Okay. Here's my new strategy. I'm going to keep max distance for all directions. And then I will loop through obstacles to get max distance, min distance. These are min distances. Yeah, okay. Set for full length initially. So initialize for full lengths. And then just like return totals of distances. Okay. This part where I loop through it and set these will be the lion's share of it. Counters or distances object up. Okay, so these are not actual 0 though, because this will be the difference between RQ and 0. Up is n minus r. Okay, so I'm assuming this is going to work as is, even though it's a little hard to make sense of right now. All right, so now I need to do looping through the obstacle. So this is for const. We have the r and the c of obstacles. So this would be something like if r, if you're in the same row as the queen, then sorry, that's the column. If you're in the same, well, the column, so c is equal to r cq, then you're worth talking about. Otherwise, we don't care. All right? Okay, so let's do that here. Same thing with this. So, whoa. So this actually counts as both up and down. That's interesting. So this is in here. Left and right is similar concept. So here's the thing. How do I make the math for this work out? That is to say, like, this 5. So if the queen is in the center and I'm in this corner 5, 1, then I should be able to do 5 minus 3 equals 2, and then 1 minus 3 is negative 2, but that ratio is the same. RQ minus R divided by CQ minus C. And that needs to equal negative 1. Because that is that diagonal. That is what that diagonal is. And it has to be relative to the RQ and CQ. If that's the case, then you are part of this up left diagonal. And I think the same logic applies to the other way. I just think it is going to be the opposite positive one. Yeah, it stays the same, right? I think so. Yeah, this is it. This is it. Okay. Oh my goodness. Oh, I think I'm getting close to this. Okay. If you're above it, if you're up, that means you're a higher number. So I need to find the difference between that number and CQ, RQ. So R minus RQ. Okay, cool. So distance, I'm going to do distances dot up is equal to math dot min of distances dot up and that. Same thing for min, or for the bottom. So I think I need to do, like, if you're positive, so if that is bigger than 0, do this. Okay, because I know you're in that row. I don't know where you are though. Are you above it or below it? So I had some technical difficulties before, but I think I can code this up fairly quickly right now. So that's what I'm going to do. I'm just going to get into it. Const diff equals this. I'm going to call it updiff. So if updiff is greater than 0, then I know that I'm counting it to be up. So I'll say, and then this is going to be like an else situation. And I can say distances dot up is equal to math.min of those two. So the reason I say .min is because you might have an obstacle in the same column, and one might be further than the other, in which case you want the minimum of those two. So I'm gonna have to like repeat myself here a little bit, but then I take the up diff. And if they're not, if it's negative, then I know it's actually not up but down that I'm caring about. So this is going to be down. I still use the number up diff there. So this is down. This is going to be up. Okay. And I think I can kind of like copy this really, because this is going to be a similar mindset here. Then the other situation is a little bit different. So how do I keep this in mind? I guess I look at the absolute difference, because it's going to be, because if this condition is already met, then I just want the larger, I just want the larger difference, right? Because if RQ minus R, so let me think about that one. But it's basically going to be a very similar logic to this. So that's what I'll do here. And the larger number will be lower right, right? So this is going to be down right is the one I want to kind of take it from the perspective of. So down right, and this is going to be down left. Or sorry, up left. So down right diff. I think. Okay, down right difference is going to be, I think it's still going to be C minus CQ, right? Because if you're down right, that means you're more, well, you could also be greater left too. You need the biggest of the two. I need the smallest of the two. So math.min of C minus Q or R minus RQ. Right? Is that? Oh man, I'm kind of blanking on this one. Okay. You have your queen here, and you're looking at this -1 diagonal. You place something on this side. It could have a larger. It could be very far right or very low down. You want the one that basically is the minimum of those two, because that is the deciding factor of what the minimum is. The number of moves, I should say. So I do want the min. I want the min of the R minus RQ and the C minus CQ, whichever one. So this doesn't make sense. Or do you want the min? Because it might be negative. So if it's negative, then you actually want the max of those negative numbers. Oh man, that's a funky situation. So row. So this is actually up. This is the up diff. Right, up diff. So if the up diff is positive. So if up diff is positive, this is going to be an up left situation. Then I want to do this. I want to take the difference, the minimum difference of up diff and C minus Q. If it's up, hold on, if it's up, oh yeah, okay. If it's positive, that means you're above the queen and to the left of the queen. So that's going to be positive either way. You want the minimum of those two. That makes sense. And that is what I would set here for this. Hold on, I think I want to do 1 minus all these then. Hold on. So the up, let's see here. So if you're going left, you don't want, so if you're at 4-3 and you're going to 4-2, you don't want, the difference between that and that is 1. But you actually want less than that, which is -1, -1 here. -1 there. And sure enough, I think this is also going to be -1. In which case, I want this to be equals. No. I don't want to do that. No. I want to do it after the fact. I want to do it here. -1 here. Wait a second. If up difference is negative, then I want this to be the absolute. -1. Okay, I'm finding flaws already. -1. Absolute there. Man, I'm like, I haven't even run anything, and this is like already getting kind of complicated already. Let me comment this stuff out real quick. I just want to see the combined distances work out a little bit right now. Distances. So I can do like object dot keys, or really just dot values. Values, distances, dot map, or I can just do reduce. Reduce. Okay. If C is not defined. C is not defined. I don't know why I put Q here. This is meant to be C, column. Okay, fair enough. I got good marks on all this stuff. Yeah, this won't work for everything. So let me just like submit it, but it's not gonna work for everything, I don't think. Oh yeah, but it should be quicker. So this is the idea. Like the problem I had before was that I wasn't running it quick enough, so I was timing out a bunch of times. So I'll have a bunch of wrong answers here, but you can see like it's definitely quick to get these answers. Okay, so I feel confident that I'm on the right track, and let's keep going. I need to see if the difference in the up direction is positive. If it is, then I know I'm going up left. If it isn't, I know I'm going down right. So that's why I'm checking here. Once I get that, I need to look at the difference between up left diff, which is literally the minimum of the up difference and the left difference, which is C minus CQ. Actually, this left difference, the left difference is, hold on. I thought left is left big? No, left is positive here. So it's literally the difference between CQ minus C, because CQ is larger. In that case, if you're upper will be larger. Okay, so this is the thing that makes sense. Okay, all right, here is the thing that I'm looking for, and here I want it not to be right, but I want it to be up. I need it to be up left. So you're up left. So up left is that, and I need to do -1 on that. Okay. We're getting somewhere, I think. So if up difference is negative, then I know I'm doing down right. Same thing kind of applies here, except now up diff is the math.absolute, and this time I think I reverse these because C is larger than CQ, so it's this way, and this is my up. Sorry, this is my down right difference. That's what I put in here. I think I do -1. This is, I'm making sure these are all positive, right? This is a positive number because C is larger, so on this is further down to the right, and yeah, the absolute there, and then I do my distances, which is going to be down right. I think that's what I called it. Down right. Underscore? These are dashes. Why is it dash if you underscore? Underscore, okay. Let me see. I have 12 tests failing, right? So if I run this, I think I should have fewer tests failing. Let me just run it one time on the test stuff, which it works, okay? So I should hopefully have fewer than 12 this time, which will help confirm whether or not my stuff is working at all. And runtime errors. Oh, come on. Give me more information, please. Okay, so let me unlock one. hopefully I can like put it in here and then run the code and see what the runtime error is from that. Thank you. RQ is not defined in, oh, line 60. Yes, that is true. It's R underscore. That's my runtime error. Okay, so it ran successfully. Okay, I got some stuff. Okay, so now that I found my error, let me submit the code. I should have less than 12 maybe. Less than 12 mistakes. If it is, then I know my code is working a little bit better. Nope, still fails. Okay, that's fair. Okay, let's do this one. And there we go. Oh. Okay, run some code. Okay, well there we go. Expected 40. And I don't think I was giving 40, so let me see what I got here. I think I was giving more than 40. I have 11 passing here, or 10 failing. So I did pass more than I was before. So I have 41. Okay, so that's interesting. So I'm literally missing one. There's a -1 here that's not quite in the right spot. So it's a one-off error. One-off error is I was not correct to put it in here because this is me calculating the difference, not the actual thing I'm resetting it to. Okay, so this should hopefully yield 40, I think. 40, okay. Let's submit some code. Come on, baby. Come on, baby. Oh, freaking finally. God, that took forever. Yeah, definitely messy. Just having all the different directions and understanding like the differences. -1 one-off errors are always going to be a thing. I need to be double checking for. But this makes sense. It is not clean. God knows there's probably a better way of doing it. I'm going to quickly check the discussion. Actually, I haven't checked discussion this entire time. Let's see what it may be a better solution. I'm sure there's. Loop through the obstacles given and keep track of the closest one to our queen in each of the 8 directions. That's basically what I did. Then we recalculate distance. Okay, yeah, that's right. Beautiful solution. I came up with this as well. Cool. So I think so. It's definitely, yeah. Look. It's massive. It's not going to be short. Everyone else, yeah. Look at these massive solutions. So I think I actually came up with one of the more efficient solutions after failing initially. So that was fun. I would say that was kind of fun. Anyway, hope that was enjoyable watching me stumble and have to redo everything. And I will see you next time.